right, so we're going to start by going over. So I need you to listen. iPads face down, eyeballs up. And then if you've got questions, I'll go over it. But hopefully I'll be able to answer them. Sorry, I should say iPads and phones. Away, please. Okay. So it's called Mathematical Valentine, okay? And it's just something fun, cheesy, silly to do in honor of this week. You can, and this is bonus, so you do not have to do it. You choose not to do it, it's 0 out of 0, okay? If you choose to do it, you can earn up to 5 points towards any test, so it will just go into your test average. Your opportunity is to create Mathematical Valentine in a series of different ways using mathematical terms. So they don't have to be used in the way that is their definition, okay? But they can be used in any kind of way. You can be as creative as you want with this, okay? You will use either paper. You could literally draw this if you're somebody that's artistic and you want to draw, cut things out, whatever it is. You could do a literal physical piece of paper. Hold, please. Wait. You could do a collage of sorts digitally. Like you could put them all on one page. It could be multi-page, whatever it is. You could do a PowerPoint, okay, if you wanted to do like almost like a flip book. Or you could, even better, turn it into a movie. If you're artistic and you can like do an animation, even better. Okay, I've seen some really cool stuff done with this. It's just an opportunity to be a little bit creative and go outside the box a little bit. The requirement is you have to include 10 math terms in any way you want to, but there has to be 10 of them. There can be one collage with all 10. If you can get it into a paragraph or something like that, you can put them all in there. If it's just 10 little cheesy little quotes, you know, like be mine, but in some way with mathematical, you can put 10 on one page. Again, you can make it like almost like a book, or you can make it a video with some music or some sound, whatever it is, okay? The rubric is just those 5 points. So overall, quality and effort, originality, creativity, minimum of 10 terms have to be used, and then how you use those geometric terms creatively, okay? If you like the one that's on here, it says I love you more than pi. That one you cannot now use, okay? That's the only one I'm giving you, because if I give you anything else, all of you will include the same thing, okay? If I show you an example, it will all look the same. So I'm not going to squash your curiosity, your creativity. I want you to come up with it however you want to. Again, totally optional. You choose not to do it, no problem. No, like less for me to grade. It's fine. But if you choose to do it, hopefully it's a little bit of fun. You will have until Friday of this week to do it. So it's due Friday at 8 a.m. no matter what. So there will be no lates on this because you have the week to do it, okay? And again, the more you put into it, the more you're going to get out of it. I said it on paper. So if it's a physical paper, then you will bring it to me, okay? I'll probably still have you take a picture of it and submit it digitally just so that I have both so I could grade them without having it here. But if it's like a physical piece of paper, I'm going to hang it up. Like, this should be fun, okay, and not stressful. Questions?
I was going to ask when it was due, but you said it.
Friday. Thank you. Okay. Any other questions? All right. If you have like an idea and you're like, what about this later, and you have a question, feel free to ask it, okay? But the goal would be, again, by Friday morning.
Wait, this is a test screen?
So this is actually from, this is algebra stuff. What we're going to do for the next, basically, week and a half, and you'll get a quiz on it, too, next week, is algebra review. So we're going to go through multiplying polynomials, factoring polynomials, solving quadratics, all that stuff, because all of those are skills you're going to need when we get into chapter 10, which is circles. So that we'll go back to the geometry book. Okay, so the good news is if you were an algebra fan, the next couple of weeks will be great for you. And if you know that you struggled with these skills, you're getting an opportunity to kind of make sure you know them again before we move into applying them with circles. So today's is called Polynomial and Special Products. The homework is still going to be on Big Ideas, but it's going to come from the algebra book. So if you end up going to if you click on book from Big Ideas for extra practice, it's going to link you back to the algebra book, okay? But it obviously go back to geometry after. So we're going to multiply polynomials, and to do this, we're going to multiply the coefficients, which is the number on the front, and then multiply the variables with the exponents. When you multiply variables with exponents, you add the exponents if the base is the same. And then we're going to go through multiplying binomials, where if there's 2 terms in each, you would FOIL. I actually just watched my son do also the box, people who want to do the box is fine too. And then obviously at the very end, you're always going to combine your like terms. So if they are the same variable with the same exponent, we add or subtract them. You always want to combine those together to make it as simple as possible. All right, so we start with just using the distributive property to multiply the variable out. So on example 1, I'm going to distribute x to the 3x squared, and that would be 3 times 1 or 3, and then x to the first times x to the second. We add the exponents, so it's x to the third. And then I would do x times negative x, which would be negative x times x, or x squared. And then I do x times 1, which is positive x. I cannot combine these because they have different exponents, so that is how I leave my answer. Questions so far? All right, 2, we're distributing. This time there's a negative on the front of that 3. So when I distribute, I want to do negative 3 times 5, which is negative 15. And then x times x, which is x squared. And then negative 3x times 2. Negative 3 times 2 would be negative 6. And then there's just x to the first. Again, different exponents on those bases, so you cannot combine them. It would stay just like that. Questions on those? All right, now we're going to do the binomial. Binomial means 2. So you're multiplying 2 parentheses with 2 terms in them. The acronym we use sometimes is called FOIL, and it stands for first, outer, inner, last. So you multiply the first 2 terms, you multiply the outer 2 terms, the inner, and the last. So first, outer, inner, last. Okay, and again, I've also seen people, I mean, you're basically just distributing the first term to each, and then I've also seen people make that little square box where you multiply the first 2 in each, the second 2, like, it doesn't matter how you choose to do this, okay? At the end, you always want to combine your like terms, so there's usually 2 terms together that you can combine to make it into a trinomial. All right, so 3, I'll do like one of each one. 3, so the first would mean I multiply the first 2 in each. So first would be x times x, which is x squared. Outer would be the outer 2, positive 4 and positive x, so positive 4x. Inner would be negative 8 and positive x, so negative 8x. And then, change my color. And then last, which would be negative 8 and positive 4, or negative 32. And then you can combine your like terms. So like terms here would be the positive 4 and the negative 8, and you get x squared minus 4x minus 32.
Yep, just like how I remember it.
Good.
And this is it?
Yeah, for foiling, yeah.
Gets harder from here, Mars. It's hard? What?
No.
I said it only gets harder from here.
All right, so for 4, again, I have seen people where you do the box. I mean, at some point we get past the box. Agreed. But some people are great like this. So 3x and negative 2, and then 5x and positive 7. So then you would multiply. In this box goes the 3x and the 5x, which is 15x squared. In this box goes the negative 2 and the 5x, so negative 10x. In this box goes the 7 times the 3x, or 21x. And in this box goes the 7 and the negative 2, so negative 14. These are then like terms, so you have to combine them. So the 15x goes first, 15x squared. Positive 21 minus 10 would be a positive 11x, and then minus 14.
I don't want to bring abundant squares.
It's not abundant squares.
It's just like something.
Yeah, it's the same concept, yes, but yeah.
Yeah,
I'll just repeat what I already said, which was that some people prefer the box. You could choose between either one. I don't care. All right, so for 5, you should have gotten 2x squared plus 10x minus 4x minus 20. Combine your like terms, you get 2x squared plus 6x minus 20. And then for 6, 28x squared minus 21x minus 8x plus 6, which simplifies to 28x squared minus 29x plus 6. Raise your hand if you got them both right. Good. Questions? Okay. All right, there are 3 things that we call special products. They are shortcuts to multiplying out binomials. Okay, so these shortcuts only save on time. They do not, like, you can't, like, you're not going to get it wrong if you go back to just foiling it out. But these do help with, again, time purposes. And it happens for 3 of the different scenarios. The first is if they are the exact same terms, but one's got a plus and one's got a minus. So it would look like an x plus 2 and an x minus 2 here. That's what the difference of 2 squares would result, or it would result in the difference of 2 squares. And the shortcut there is just to square the first term. So I would square x and I get x squared. Square the second term, which is 2, and I get 4. And then put a minus between them. So that's one of the shortcuts.
What if it's both plus?
You can't do it. It has to be 1 plus and 1 minus in order for this to work. The 1 plus comes in the next part. Mars.
What if it was minus then plus? Like minus.
Doesn't matter. The order doesn't matter. As long as one's positive and one's negative. The second is the perfect square. So it's actually a square of a sum in this case because it's a plus in between it. So if it is just one set of terms like x plus 3 squared, okay, then the shortcut, and it's not that much of a shortcut, so you kind of get to determine if you're going to use it. What you cannot do here is distribute that exponent. This does not become x squared plus 9. That is wrong. You can expand and FOIL it, or you can use this little shortcut, which is square the first term. So that would be an x squared. That's the first term. Square the last term. So I'm going to square the 3, and that's the last one, which would be positive 9. And then double the product. So multiply these two together, and you get 3x, and then multiply it times 2, and I get positive 6x. So that's when it's a sum. Square the first, square the last, double the product of the 2 terms. And then the last one is almost exactly the same. The only difference is the sign on the term in between, or the sign in between them. So if it said x minus 3, I would still square the first one, square the last one, and then multiply these two together. That's where the negative 3 comes from. Double it, and it's negative 6x.
So there's only one minus this time.
Correct. The first and the last will always be positive because they're perfect squares. So when even if it's a minus, if I square negative 3, it's still a positive. So when we do these together, we'll do them with the shortcuts, but of course you can always fall back on foiling. Like you could just expand and FOIL that out and you still get the same answer.
That's what I do, because sometimes I just forget it. And then
Okay.
it gets pretty messy.
All right, so 7, both the same terms, but one's a plus and one's a minus. So this is that first shortcut, which says,
A2 minus B2. I mean, A squared minus B2.
good, so 2x is my A, and 3 is my B. And I put a minus between them. So I squared 2x. You can either distribute the exponent or literally multiply 2x by 2x. Either way, you get 4x squared minus square the 3, and it's 9. This one obviously is easier to use the shortcut. Yep, same thing. So the first term would be 4a. I'm going to square that. The second term is 5b. I'm going to square that. I'm going to put a minus between them. I get 16a squared minus 25b squared. All right, then 9 is your square, your perfect square. And again, this time it's a minus. So I square the first term, 6x squared. I square the last term, 5 squared. And then I double the product. So negative 2 times 6x times 5. This is 36x squared. 6 and 5 are 30 times that 2. And I get negative,
60.
Good. And then 5 squared, 25. Questions on those?
No.
All right, you do these. All right, so 10, the first term is now 5. Square the 5, I get 25. The last term is 8x. I don't need the sign because I'm always going to square it. It's always going to be positive. 8x squared would be 64x squared. Multiply the two together, and I get negative 40x. Double it, and it's negative 80x. And again, you can just expand and FOIL if the shortcut confuses you. Yes.
Can you actually just like do like 64 squared? So it'll be like.
In the order, you mean?
No, like to take off the square. So it can just be.
Can you square root it, you mean?
No. Wait.
I have no idea what you're saying.
I'm wrong.
Okay. Okay. So the answer to your question was no then?
I got it right, but like.
Oh.
I was just wondering.
Okay. All right, 11, square the first term. 8x squared is 64x squared. Square the last one. That's a positive 9. Double the product. So a positive 24x times 2 is 48x. Raise your hand if you got both those right.
Let's go 2 more.
Questions? Okay. All right, now we're going to start factoring, and we're going to break this down over the course of the next couple of days, okay? Today, we're just going to factor your, like, traditional factoring, which is the first term. There's 3 terms on this one, okay? There's nothing other than a 1 in front of the x squared on the front. God bless you. So in that case, you're looking for the factors of the last term that sum to the middle. In the example that's there, it's x squared plus 9x plus 18. It's a positive 18, so I can go through all of, hopefully we'll get better and we won't have to do this full out every time, but I can go through all the factors of 18. Positive 1 and 18, 2 and 9, 3 and 6. And then because they're both positive, I'm looking to see which one's sum would add up to 9, and that's the 3 and 6. And then I put them each behind an x. So x plus 3 and x plus 6.
Oh, I remember this.
Good, because factoring is huge. Okay, factoring is not something that goes away anytime soon, folks. So as you get better at it, you don't necessarily have to write out all those combinations, but for now we're writing them out. When you have a positive at the end, these are all going to either be both positive or they could both be negative, and that's when you look at that middle sign. If it's a positive and a positive, everything's going to be positive. If it's a positive at the end but a negative in between, so if it had said x squared minus 9x plus 18, then all my factors would have been negative. And this would have been the combination that adds up to that negative 9. So if the last term is positive, they are all the same signs. Whether they're both positive or both negative is determined by the middle term.
What if the first is negative?
The first one's not going to be, the first one's always going to be x squared for now.
I'm talking about the middle one.
Is the last one positive?
Yeah.
Then they're both negative. So if the last term is positive, they have to have the same sign. Then you go to the middle term, and that's the sign. So if the last is positive, this is positive, and this is positive, then they all have to be positive. Yeah. If this is positive and this is negative, then they have to be negative. I'm not, wait. I'm not there yet. So far on that, we're good. If the last one's positive, yes, we go to the middle term. If the last one's positive and the middle one's positive, they're all positive. If the last one's positive, the middle one's negative, they're all negative. If they are different, if the last number is negative, now it's a combination of positive and negative. One has to be a plus and one has to be a minus. And we go to the middle term. If the middle term is positive, the bigger number is positive. If the middle term is negative, then the bigger term is negative. So it takes on the sign from the middle term. We're going to practice this, but that's the idea behind it. Mars.
So how would the one with x squared minus 9x plus 18, how would that look?
It would be x minus 3 and x minus 6.
Okay.
You can put it right on my desk, Sebastian. You can put it right on my desk. All right, what? Yes.
And what happens there?
I just went over that, but I'll go over it again, right? So this one says, this is in words what we just said. If C is positive, if the last term is positive, then the factors have the same sign. And B tells you, which is the middle term, tells you whether those factors are positive or negative. So last term is positive, you take the sign from the middle two. And they are both, from the middle one, and they're both the same. If B is positive, both factors are positive. If B is negative, both factors are negative. That C is positive. So if you look at this one, the last term is positive. And then you go to the middle term. What does that tell you? They're both positive. So if I go through the factors of 36, it could be 1 and 36, 2 and 18, 3 and 12, and right there is the ones that add to 15. And they're both positive. So x plus 3 and x plus 12. The good part of factoring is you can check every single answer by foiling it back out and seeing if it matches. If I FOIL that back out, I'd get x squared plus 12x plus 3x plus 36. Combine my like terms, and it matches the question.
It doesn't matter what if 12 goes first or 13 goes first?
Correct.
Or 3 goes first?
Correct. Doesn't matter.
Doesn't matter.
Does not matter. Order does not matter. Nope.
So, okay. Wait, so the middle one's the one that adds up to, right?
Correct. Factors of the last, so multiplies to give you the last, adds to give you the middle. All right. What are the last term is positive, middle term is positive. What are my signs going to be? Positive. I could do 1 and 12, 2 and 6, 3 and 4. 3 and 4 is the one that adds up to 7. So I get x plus 3 and x plus 4. Questions on those?
No. Man.
Thank you. All right, last term's positive, middle term's negative. What's that mean?
Negative.
They're both negative, so it's going to be a -1 and a -15, a -3 and a -5.
That one.
That one's the one that works. All right, last one's positive, middle term's negative. What are my signs going to be? Negative.
2 and x. Sides are gonna be
-1,
negative.
-6, -2, -3. Which one gives you the 5?
The second one.
I'm at the wrong one.
Thank you for sharing.
What was it?
All right, now it says when C is negative. So if the last term is negative, then the factors have opposite signs. One's got to have a plus and one's got to have a minus. And the sign of B tells you which one is positive or negative. B matches the larger number. So if B is negative, the larger of the two is negative. If B is positive, the larger of the two is positive. So again, whichever one is greater matches the sign of B. So it'll look something like this. The last term is negative, so I know one's got to be positive, one's got to be negative. Then I go to the middle term, and it's positive, which means the larger of my factors has to be positive. So this could be -1 and +20, -2 and +10, -4 and +5. And that last one is the one that adds up to a +1. So it's x minus 4 and x plus 5. And again, like the other ones, I could FOIL that back out and check it. Questions on that one?
Now, both are negative.
Both are negative, which tells you what?
6 minus 3.
Different signs, right? Different signs, larger's negative. So it could be +1 and -18, +2 and -9, +3 and -6, and that's the one that works.
Wait, can it be 6, -3?
No, then it would be a +3. So the bigger has to match, this is negative, which means the bigger terms have to be negative. X plus 3, x minus 6.
Can I do x minus 6?
Sure. As long as the negative's on the 6 and the plus is with the 3, the order does not matter. To something called the difference of two squares. This is the reverse of our shortcut. If there are two terms, so it has to be two terms, they are both perfect squares, and there's a minus between them. Those three things have to happen. Two terms, both perfect squares, minus between. And then if that's the case, you square root each of them. So this would be an a squared minus b squared. You square root the first, that goes in the first spot. You square root the second, that goes in the second spot. One gets a plus and one gets a minus. So looking at this example, there are two terms. They are both perfect squares, and there's the minus between them. So I'm going to do two parentheses. I square root the first term, which would be x and x. I square root the 9, 3 and 3. One gets a plus and one gets a minus. And again, order there doesn't matter. It could be minus then plus. This is called the difference of two squares. Square root, repeat. One gets a plus, one gets a minus.
This one's easy.
Yep. Okay, last one. Are they both perfect squares?
Yeah.
Is there a minus between them?
Yes.
So I do two parentheses, square root the x squared, square root the 64.
Plus 8.
What if the number is not a perfect
Then you can't factor it this way.
What if it's a plus?
Then you can't factor it this way. If it's a plus, it's actually prime. It can't be factored at all. So like I would say the only other variation is if you see like 25x squared minus 64 y squared, that tends to throw people. What would be the square root of 25x squared?
5x.
5x. What's the square root of 64y squared? 8y. And then one gets a plus and one gets a minus. Okay, and again, it has to be the difference two squares, so it can't be a plus between them. That would be prime. If they can't be factored, you literally say prime. Questions? How many of you are happy to bring algebra back? How many of you are dreading every second of the factoring? All right, not bad. Okay,
I'm fine.
good. Thank you. All right, your homework is on, again, it's on Big Ideas, but it links to the Algebra 1 book. You need to show the work. And if you want to get started on your Valentine thing, obviously, don't forget that's due Friday. So every day when we have a little bit of, like you have 7 minutes at the end of class, I would say, I would encourage you to work a little bit on it. So you could find, even if you're just like Googling some cheesy math Valentines,